Systems of inequalities, also called linear programming, can be solved using the following steps. We want to graph the first inequality, then we want to shade in the side of the boundary line where the inequality is true. Third, we want to graph the second inequality, and step 4 would be shade in the side of the boundary line where the second inequality is true. Then the last part is the solution to a system of inequalities is all the values, the area where both inequalities are true. Or we could also say, or where the two shaded regions overlap. So let's give example 1 a try. This dotted blue line represents this first inequality. We need to pick a value, doesn't matter which side, but I'm going to pick an easy one to substitute in. I'm going to pick 0, 0 as the coordinate point to see if this is true. When I substitute 0, 0 in, I get 0 is less than 3 times 0 plus 3, which is a true statement. 0 is less than 3. I know that this right side of the line is the shaded region for my first inequality. Now let's go ahead and do the same thing over again with the second inequality. So this one here, I'm going to also substitute in the point 0, 0 into the second inequality, and this will give me 0 is greater than or equal to 1/2 times 0 minus 2, which, checking 0 is greater than or equal to -2 is also a true statement. So both of these statements were true. And so I'm now going to highlight this region on the second graph. So I'm picking 0, 0 as a point, but I could pick quite literally any point on the graph. And where the two segments overlap, notice it turned green, that is my interval or area where this system is true. So this part right here is the true statement. Now in future videos we'll talk about these intersection points as being critical to the bounds of the solution, but for now just being able to graph the two inequalities and find where the overlap is the biggest important part. So in example 2 we're going to pick the point that we want to use as a test point, and I'm going to say that maybe we should pick 1, 1. That's a very easy one to test. It's nice to substitute in. So 1, 1 is my test point. So for the first one, this blue line is my first inequality. So I'm going to substitute in 1, 1. And this gives me 1 is greater than or equal to -4 times 1 plus 3. And so we need to check to see if that's true. if I have 1 greater than or equal to negative 1, is 1 greater than or equal to negative 1? Yes, that is true. So this one is a true statement. So I can highlight this portion of my graph for the blue line. Now let's try substituting it into the second one. At 1, 1, this will give me 1 is less than 2 times 1 minus 3, which would simplify to 1 is less than negative 1. And this is not a true statement. So that means that this side of the graph is not true for the dotted line inequality. So that means I need to highlight or select the other side of my line as the true side. So it doesn't matter which point you pick, because if it's an untrue statement when you substitute the value in, you know you just need to highlight the other side of the graphed line. So the location that is true for both, or is true for this system, is this one right here.